Okay, let's start talking about absolute value inequalities. And quickly, I'm going to remind you that the solutions to an inequality are the values that satisfy the inequality. So let's look at a simple absolute value inequality. The absolute value of x is less than 2. So a reminder, our geometric interpretation of the absolute value, this statement translates to a number whose distance from 0 is less than 2. Now obviously there's more than one number that has a distance less than 2 from 0. Let's look at a number line. So here's a number line centered at 0. 1 has a distance from 0 that's less than 2. 1.5 has a distance from 0 that's less than 2. All the way out to 2 itself, just not including 2. We can also go out to negative 2. So I'm going to put open circles to indicate that negative 2 and 2 don't have a distance from 0 that's less than 2, but all of these numbers in between do. 0, 0.1, 0.12, 0.5, 1.5, all of these numbers satisfy this inequality. They all have a distance that is less than 2 from 0. So if I wanted to write this out, I could say that x must be less than 2. But writing this isn't enough. It's not enough to say that x is less than 2 because that includes numbers like negative 3 and negative 5. So x has to be less than 2 and x has to be greater than negative 2. So x has to be both less than 2 and x has to be greater than negative 2 to have a distance less than 2 from 0. Okay, so we can express this. We're familiar with the compound inequalities. This is negative 2 is less than x is less than 2. Let's look at how this translates into a more complicated problem. So say I have the absolute value of x minus 4, closed absolute value, is less than 2. I mean, the interpretation is still the same. It's only I don't have x in between the absolute value. But what I do know is that whatever this number is, this x minus 4, its distance from 0 has to be less than 2. So x minus 4 has to have a distance from 0 less than 2. That means that x minus 4 has to be less than 2, and x minus 4 has to be greater than negative 2. So this will make it so that whatever value x is, as long as I plug it in and I subtract 4 from it, the number I get is between negative 2 and 2. That absolute value will be less than 2. So let's solve these two inequalities. I add 4 to both sides, and I have x is less than 6, and do the same thing over here. Add 4 to both sides. X is greater than 2. Okay, and as a compound inequality, this is 2 is less than x is less than 6. Let's look at this graphically. So here's a graphical representation of the solutions on a number line. I've got 1, 2, 3, 4, 5, and 6. We'll go out to 7. The actual solution should be between 2 and 6. So here's 2 and here's 6, and it should be all these numbers in between should satisfy this inequality. A quick way to verify that, and this doesn't completely verify it, but we can spot check some numbers. So for instance, if we wanted to see if 1 is a solution, we plug 1 into the original inequality, x equals 1, and I see that the absolute value of 1 minus 4 is the absolute value of negative 3, which is 3, which is not less than 2. So I know that this is not a solution, which is what my answer tells me. It's not a solution. It tells me that the solution should be between 2 and 6. Let's pick a random number in here like 3 and verify that it works. Let's make x equal to 3. So I have the absolute value of 3 minus 4. 3 minus 4 is negative 1. So I have the absolute value of negative 1, which is of course less than 2. Hey, so 3 is a solution. So this is just an introduction to solving absolute value inequalities. In the next video, we'll look at how this applies to greater than, using the greater than symbol.